Okay, here we go. Yes. Yep, we turned it in. You put it in the box thing. And you will get your homeworks back tomorrow, so you have them to help you and study and all that stuff before your quiz on Friday. Okay, so you'll get them back tomorrow. All right, so key features on a graph. There are 6 of them. We're going to find our intercepts, which we've been doing, right? X and Y intercepts. We're going to find intervals where the function is increasing or decreasing. So we're going to find pieces of my graph going up, pieces of my graph going down. Okay. How do we always read graphs? Just like a book, we always go left to right. Okay, so that's how I'm going to know where's it going up and where's it going down. I'm going to scan from left to right. That's going to show me those interval pieces. Okay, we're going to find intervals where the function is positive or negative, meaning where is the function above my x-axis and where is my function below the x-axis. Okay. Symmetry we've already done. What identifies the symmetry of a quadratic? What's in the middle? Axis of symmetry and your vertex. Okay, those pieces are what's going to help you when we get there with our symmetry. All right, and then we're going to talk about end behavior. So how are the ends behaving? What do they do in a quadratic? They either both go up or they both go down. And there's just a mathematical way to write that instead of just saying up, down. Of course, we got to make it more fun. We're going to use like infinities and stuff. Oh, yeah. You want this? Sure. Do you want a pencil instead of a pen? Since yours is having issues. And then domain and range, which is on every single graph. And you've done them before. These are all in every graph, by the way. But domain and range is talking about what x values exist on the graph itself, and then what y values exist on the graph. So on the actual parabola, what are the x's, what are the y's? Okay, before I start going into description of all these fun things, I would like to talk about what interval notation looks like. Okay, because you keep there, the word intervals are there twice, right? I see it. Intervals, and we're even going to use intervals with domain and range. Okay, so I don't think we've done that before, which is what I assumed incorrectly earlier today. So we're going to talk about what interval notation is. So I would go to the back of your paper real quick. Back of your paper. Okay. Interval notation. It looks like a coordinate point, but it is not. What's happening is we're doing the lowest value to the highest value in that interval. Sometimes it's x's, sometimes it's just y's. It depends on what we're talking about. Okay? When we're doing interval of increasing and decreasing, okay, we're going to have a function. It's going to go one way or the other. We're going to move left to right. Okay? This piece is decreasing, right? It's falling down. This piece is increasing. What we do is we go from left to right, so that means we're going to use x values for intervals of increasing and decreasing. So we're going to do the lowest x value to the highest x value of where it's going down or where it's going up. Okay, so intervals of increasing and decreasing, because we're moving left to right, that's my x-axis, we're going to use x values in my notation. Okay, so we would use the lowest x, and then we would do the highest x that go for that piece. Okay, when we're looking at positive and negatives, okay, we're looking where my graph is above and where my graph is below my x-axis. Okay, so here, let's give another one. I'll make it go upside down this time. Okay. Okay, so here we're looking, where is it above? Okay, and so this is above, all positive. This is positive. because all of the y's are positive up there, right? And then down here, this is showing where we're negative, where my y values are getting negative and getting smaller, okay? We still use our x values because we're still referring to where it's crossing the x-axis. So between this x value and this x value, we're either above or below the x-axis, okay? So positive and negative, we're still going to use x values. All right, domain and range, okay? These are different. When we're doing domain, are we looking at x's or y's? So domain values are the x values on the graph, okay? So when we're looking at domain, we're looking at a parabola. I'm seeing what are all the x values on that parabola. So we're looking, so we would use x values here. For range, we're looking at all of the y values, right? So this notation would just be using our y values. So the lowest y, the highest y. The lowest x, the highest x. Now we can kind of go ahead and do domain. Will it ever stop moving left and right? For parabolas, no. So this will always go from negative to positive infinity. That's how we show all of them. They will all be there because the smallest x that exists is negative infinity. The highest x that exists is positive infinity. Okay? Because of those arrows, it's not going to stop. My y values, though, they have a restriction, right? This graph does not go forever up and down. It goes forever up. But look, it stops right here, right? So we will have restrictions when it comes to my range, and it all depends on the vertex. So our vertex is going to help us. And we'll get in more details with that in a minute. But I just wanted you to understand what interval notation is and how we're going to write our answers. Because that looks a whole lot like points, and we're going to be putting infinities in there. So I wanted to clarify all of that first. Okay? Questions about any of that? Okay. Now let's describe those pieces that we had put on before. So go back to the front. We're going to describe each piece. Okay. When we're talking about x-intercepts, how many could I have? We could have 2. We could have 1. Or we could have none. Good. Like that's what our discriminants told us, right? It could cross twice, just once, or none at all. Okay. How about y-intercepts? How many y-intercepts are we going to have? We will always only have 1. Okay? Always, always, always. It will always cross your y-axis. Sometimes it might not show it, like your homework the other night, right? Number 6. It didn't show it crossed the y-axis, but it did. It was just like negative 72. So even if it doesn't show it to you, you're only given a little window of that parabola. Okay? They will always cross the y-axis. All right, and then the symmetry of a quadratic, we already kind of talked about this. What did we say was that marks the symmetry? The vertex. We're symmetric about the vertex. That turning point is what's going to cut it in half. So when I'm looking at increasing and decreasing, the vertex is where it turns, right? So either up to the vertex is increase or decrease, and then after the vertex has to be increase or decrease. Ready? Couple more. End behavior, okay? We are going to have positive and negative graphs, correct? A positive quadratic, both of my ends are going where? They're both going up. It looks something like this, okay? The fancy way we write it, okay? Just look at it for a second. Let me explain it to you. Don't freak out on me. Don't freak out. This piece right here will be the same every single time we do end behavior. This piece is the only piece that actually tells me what the ends are doing. So to translate, this first half, as x approaches positive infinity, that is over here, right? And my x's are getting bigger. My y's are also, excuse me, getting bigger. Okay? So this is saying as x approaches positive infinity, so as we move to the right, my y's, they're also getting bigger. So my y's are going up to positive infinity. The second line, as x approaches negative infinity. So if we move the other direction, if we're looking at the left side, that's where my x's are getting smaller, right? As we approach negative infinity, my y's are still going up. Okay? So instead of saying up and down, we're going to get fancy and say infinity or negative infinity. Okay? But what's nice about parabolas is that your ends always match, right? So for negative, that whole thing is going to be the same, except what are my last two symbols going to be? Negative infinity, yes. So remember, this part will never change. I'm even going to probably type this on the paper for you. I'll give you that much. You have to tell me this piece and this piece. Okay? So as x goes to positive, that's over here on the right-hand side, my y's, look at that, they're dropping down. They're going down to negative infinity. The other side, this is my left, as x goes to negative, as my x's are getting smaller, my y's, here they are also going down. So for parabolas, they'll either both be infinity or both be negative infinity. Okay. Our functions are going to change over the course of this class. So sometimes they will be opposites. Okay, like if we have a cubic, one goes up, one goes down, right? And other things, we'll do rationals, logarithms, exponentials, all those good things. When asymptotes come in, there might be a number there. So we'll keep playing with these. They're not going to go away. All right? So that is in behavior. Now when we talk about domain and range. Yes? You sure? Okay. Domain and range. Remember, domain, we already talked about this, it was always negative to positive infinity because it's never going to stop left to right. We also already talked about how my range does have a restriction. It's only the vertex and up, or it's the vertex and down. We have to remember, with our notation, it goes smallest to biggest. Okay? So this guy right here, my vertex is the smallest, right? So we'll go vertex and up. But over here, my vertex is the highest. So we're going to go down up to the vertex. So it's going to look like that. So here, my vertex was the lowest point. And that's how we start with K. Here, my vertex, whoa, that's not what I wanted. There we go. My vertex was the highest point, right? That's the highest y value it's going to have. So that's why it was at the end. Because we always do lowest and then highest. Okay. Ready to do something with it?
No.
How about now?
No.
Never.
How about now? Okay, so what we are going to do, so your first little group of A through H, we're not going to do that first. That's what I'm going to do different for 5th period, okay? I'm going to go to that next group where it's A through J, and you're given a function at the top. We're going to do those first, okay? That you all understand? So we're going to do the middle
the middle section at the bottom. We're going to start with this A through J piece. Okay, which apparently I got A and E happy, but you got it. It's right on your paper. Okay, so we have a function. On the back, we're going to kind of graph it as we move forward because a lot of this is very visual to see where it's increasing, see where it's below the x-axis, okay? And there's not a whole lot of room right here. So make sure on the back we're going to sketch it as we work through. Okay? Our x-intercepts. Well, hold on. Before I even do that, when I start graphing this, where am I going to start with? A graph. And what are we going to graph first on it, though? Our vertex. So where is it? What is our vertex? Our vertex here is -1 and -3. So mark that first. So it looks like we have -1, -3. About right here. Okay, so that's how we're going to start. We know it's going to open up or down. It's going to open up. So am I going to have x-intercepts? Yes, we are. Good. How are we going to find those x-intercepts? Plug in 0 from my y. Good. So 0 equals x plus 1 squared minus 3. Tell me what to do. I heard someone say it. Plus 3. Oops. I said plus, so I wrote it. There we go. Equals x plus 1 squared. Now what? Square root. This gives me positive and negative. Square root 3 equals x plus 1. Good. Subtract the 1 over. -1 plus or minus. Go away. The square root of 3. But because we're graphing, what do you have to do? Plug them in, or get the decimals. Put them into your calculator and get the decimals. Because you don't know where -1 plus the square root of 3 is right now. I know what it is. You don't know what it is. So we got to practice typing this in. Because if we go to graph it, we got to be able to see it. Okay? Yes, sir. Adam, was your hand raised or you just stretching? Reaching for a calculator? You're a little far away. Just a little bit. So make sure you're using the calculator you've been working with, because they are all different on how to type this in. If you need me, let me know. And we should be getting, I'm pretty sure we have, is it -2.7 and 0.7, I believe? Okay, make sure you're getting those values. So 2.7. 0.7-ish right there. So we're going to plot those points. So it's a little bit between -2, -3, and then almost at +1. Before I make my U, though, we are going to put one more point on there. That's our x-intercept. How are you going to find your x-intercept? Almost. We just made out y equals 0. So this time we're going to make x equals 0. Yes, so do that and find your y-intercept. Yes, ma'am. All right, so for you, you're going to, you get to type it in as you see it. Okay, so you're going to do your negative, right here, -1 plus, and then see your square root symbol right there? Square root of 3. Enter. Okay, and then to do the other way, for your calculator, you can just push the up arrow, and then just make that a minus, and it'll give you the other one. Okay? All right, what is our y-intercept? -2. Good. 0 plus 1 is 1. 1 squared is 1. 1 minus 3 gives us negative 2. Well, where did that just go? Whoop, there we go. Oh, negative. There we go. Okay. So something like this. Okay. All right, intervals of increasing and decreasing. We talked about it earlier. Do we care about my x or my y values? We care about my x values. Okay? So increasing is where my graph is going up, right? Decreasing is where my graph is going down. So we only care about the x's. I only care about negative 2.7. I care about the vertex of negative 1, and I care about the other x-intercept of 0.7. Those are the 3 x values we have on our graph. We're going to use all of them. Okay? If I'm walking across left to right, am I going to slide down or climb a mountain first? We're going to slide down that parabola first. So is it going up or down? It's going down first, and then we're going to climb up, right? So my increasing interval is going to start, right? We're going to start at negative 1, and we're going to continue on forever because we don't stop at 0.7, do we? We keep going. We keep going. So what x are we going to stop at? Infinity. Okay? So the lowest x value to the highest x value of where our graph is going up. We started at the vertex of negative 1. That's where my direction changes. From there, if I was walking, I would be walking up the rest of my parabola, increasing. Okay? Decreasing, where would I be falling down? The first half, right? So what is the lowest x value? But it's even happening before that, isn't it? Yeah, so we're starting all the way at negative infinity. And then as we walk across and we fall down, where will I stop falling? At negative 1, which is my vertex. Good. So for increasing intervals, looks like the only x value we used was the vertex x value, right? Okay. We will use the other ones. I didn't lie to you. They're just not going to be used in increase and decrease. They will be used in positive and negative. All right, so increasing and decreasing here, we only care about the h value in our vertex. It's either negative infinity up to that point or that point to infinity. That shows left side or right side. Okay. Okay, our positive intervals. Okay, we're looking at where on my graph am I below the x-axis and where are we above the x-axis. Okay, so positive means above x-axis. Negative means below. Okay. So looking, what pieces are above the x-axis? I see 2 of them. Do you see 2 of them? If I was walking across this parabola, this is all above the x-axis until I reach this point, right? That is above. And then I dip down, but then starting at 0.7, I'm back above again. Positive, negative. So, positive intervals. How do I say the beginning? Negative infinity, yep. And when, that is a terrible infinity. I'm usually good at these. Ooh, okay. Concentrate. Better. Okay, from the beginning, and then where did I start to dip below it? Negative 2.7, yes. And there was another piece, right? This piece was above. And this piece is above. So we dipped down below, but where did I start getting back on the positives again? 0.7, and we were positive until infinity. Okay, now we're going to see where we are negative, meaning where we are below the x-axis. Do we agree that there's one piece of this graph that is below? Yep, and where does it start? It starts at negative 2.7, and it ends, and it ends at 0.7. So there was just one piece below, and there are two pieces above. How was that? Because I did this differently from earlier. So give me feedback. Yes? Okay. Yes. Yes. So positive and negative, yep. Jimmy noticed my next pattern. My positive and negatives, we use the x-intercepts. Yep, absolutely. So increasing, decreasing, we only compared it to the vertex, okay? My positive and negative, we will always use the x-intercepts, yes. All right, next piece, we got this, symmetry. What if I said axis of symmetry? What's the axis of symmetry here? What's -1? X or Y? So this is our axis of symmetry. Nope. Because if we lay our parabola on its side, now it's not a function because it doesn't pass the vertical line test anymore.
Yeah, true. Oh, we'll go back to the basics.
I know, fun stuff. But if I take the bottom half away, it becomes a square root.
Yeah.
Which makes sense, right? Isn't square root inverse of square? But you can't have negative square roots on a graph because we only use real numbers. So you can lay it on its side, but that's just a different function. Different function, that's square roots. We're just doing squares. Okay, in behavior. So I told you I would give you this much. So let me show you. So, as x approaches positive infinity and negative infinity, my y is going. Okay, so this is how much I'm going to give you. And you have to fill in the end. So my ends are going where? My ends are going up. So how do I say up, though, in math without saying up? Infinity. The symbol we're going to use. So increase is technically an answer, but I was looking for the symbol. Infinity. So they're both going up. Yep, because x going negative just means the left side. X going positive just means the right side. So yeah, both are still going up. All right, almost there. We got this. Come on, change my color. Fine, don't change my color. Color's not changing. Okay, domain, we always said was what? All of the x's. How do I say all of the x's? What's the lowest x we can have? Negative infinity. What's the highest x we can have? Positive infinity. Yep. So there's my domain. We talked about range, though, didn't we? Range is special. It's all about my y's. Yep. And we have to look at my, not y-intercept, because that's not my lowest y value, is it? The vertex is going to show me where my y's either stop or start. Okay, here, what is this, -3? Is that the lowest or the highest y value? Lowest, that's how I'm going to start it. So I'm starting with -3. That's the lowest y I have. And what's the highest y we have? Infinity. To infinity and beyond. It would be -infinity and then the vertex. Yep, the lowest and highest. Okay, so I did that different than all my other classes. Tell me how you feel. Besides, it's a whole lot of information, but are you confused on any of the pieces? Besides it just being a lot. Okay. All right, we're going to answer the always, sometimes, never questions next. Okay? Those always, sometimes, never things. Always, sometimes, or never. Quadratic functions have two x-intercepts. Sometimes good, because we could also have one or none, right? Good. All right, quadratic functions have one y-intercept. That is always going to happen. Very good. All right, quadratic functions are increasing. Sometimes, let's see. Yes. Sometimes they are increasing, because the other times they're doing what? They're decreasing. They're going down. All right, quadratic functions are symmetric about the y-axis.
Never.
This is sometimes. So this is if there's no horizontal shift. Okay? If from the parent function where my vertex is 0, 0, if it only gets shifted up or down, it's still on the y-axis. Okay? It only is not going to be that way if it got shifted left or right. So sometimes it is still on the y-axis. All right, quadratic functions are symmetric about the x-axis. This thing. May they be like this? Never! Never. That would mean that they fell over. That's a whole different function. We're not doing those. All right, last one. In quadratic functions, as x approaches infinity, y approaches negative infinity. Sometimes. When does this happen? When the graph is down, when my whole graph got flipped upside down. Good, good, good. Good job. Okay, so you have a half sheet. I would like you to work on that for what, a whole 1-2 minutes? Maybe just look at it. So the first half is an always, sometimes, never, like we just did. Number 2, it is multiple choice. Number 2 is multiple choice. You're telling me when is this happening, A, B, C, or D. All right. Number 3, my advice for number 3 is to write that in vertex form first. Okay, so that kind of ties into last week. So my hint for number 3, rewrite that as vertex form first. Okay, and then answer questions. You don't have to. You could do it this way. And I would also suggest graphing it as you do it. All right? Good job.